In 30 it says a pair of similar triangles. So again, we're looking at two triangles that have the same basic form. They have corresponding heights of 8 and 3. And again, so those are similar to each other. If the area of the larger triangle is 18.2, what's the area of the smaller triangle? Okay, so once again, if you wanted to, you could find the corresponding height. You could then use the ratio of parts to find, or I'm sorry, the corresponding base to this height of 8. You could then use the ratio of parts to find this base, and then you could multiply 1/2 base times height. Okay, it is possible to do that. Okay, there's nothing wrong with it, other than there's a faster approach to this. And again, the faster approach is when you're working with similar figures, if you can identify ratio of parts and areas, it might make things easier. So our parts have a ratio of 8 to 3. That means the ratio of their areas is going to be what to what? 8 squared, or 64 to 9. So our conversion factors for area is either going to be 64 over 9 or 9 over 64, right? These are the factors that the area will change. Okay, so in this question, it's asking you what's the area of the smaller triangle. So we need our area to get smaller. Can 18.2 get smaller by multiplying by 64 over 9 or 9 over 64? Right, so to find this area, if you take 18.2 and you multiply it by 9 over 64, you'll get your solution. And so if we do that math, 18.2 times 9 divided by 64, you get approximately 2.56. And the units are inches squared. And so that's how you can find what that's equal to. Yep, yeah.
What is the P of this?
Parts. So the P is just ratio of parts, A is the ratio of areas.